Assalamualaikum warahmatullahi wabarakatuh. Hello, I'm Sudra Irawan. I'm very happy today. I can meet virtual with researchers in this international conference ICAE. On this opportunity, I will present the result of the research entitled An Application of Aermod Modeling and Geographic Information System to Predict Emissions Spreading Patterns. My research team consists of Faroki Dinda Rasarandi, Wella Azhani, Rizka Revani. The increasing in urban activity, such as trade, transportation, household, industrial farmland, and agriculture, has caused most of the air pollution problem. The result in decreasing the air quality. One of the main sources of the pollution in the activity of the industrial sector, where biomass, burning, and resulting emission have an opportunity role as a source of emission in several areas. The impact of the pollution caused by industry can give rise to public health problems and various health issues, including respiratory and cardiovascular disorder, high blood pressure, lung cancer, and even death. The cement industry is one of the industrial that use high temperature heating in the production process and is one of the sector that emit the high level of pollution into the air. The main fuel used in the coal, the main raw material is limestone. The dominant emission resulting from the cement manufacturing process area particle in form of dust and gas such as the sulfur dioxide and nitrogen dioxide. According to chimney from cement industry plant are some of the biggest contribution to potential source of the pollution, especially in urban development. In the Batam city, there is an operation cement industrial, namely PT Cement Indonesia. Emission resulting from the activity of PT Cement Indonesia can use the pollution. Some of the waste may exceed the air emission quality standard set by the government. Large industry such as the PT Cement need to study to spread of air pollution coming out the chimney by using a model to estimate the effect that might occur. Based on the described above, this study aimed to produce map of air emission modeling for sulfur dioxide, nitrogen dioxide, and particle dust of the PT Cement Indonesia with an average of 6 hours, 12 hours, and 24 hours in the period of 6 months on the day of the measurement, as well a windrow map to determine the direction of spreading pollutant emission. The feature one of the Gauss dispersion model or Aermod. The Gauss dispersion model can be used to calculate or the prediction concentration of the pollution from the emission source, such as the vessel and chimney. The number of emission release can be determined from the actual process or measurement. For the point source and the approach used in the modification of the Gauss function by using 3 parameters, namely emission source, meteorology, and topography. Illustration of the spreading process of pollutant concentration whose source the emission comes from factory chimney. Air pollution released from the factory chimney will be spread by the wind in the X direction. The Z direction is the height of the pollutant. H is the effective age of the emission, the result from the total height of the factory chimney and the emission burst. A Geographic Information System, or GIS, is a computer system for capturing, storing, checking, and displaying data related to position on the Earth's surface. GIS can show many different kinds of data on the map, such as the street, building, and vegetation. This enables people to more easily see, analyze, and understanding pattern and relationship. Geographic information system can be used for waste distribution. Tool and material in this research used in this study are follow. Number one, chimney emission the test data from measurement. Number two, meteorological data and data obtained from the National Oceanic and Atmospheric Administration website and webgis.com. We are flood software to create the windrows map. And number four, Aermod view software to process meteorological data. Aermod view software to processing terrain data, and Aermod view software to processing emission data. The feature show is the step of the research starting from field data acquisition, processing of data, to the stage of analysis and interpretation of the processing result. In the determination of the interval class to the emission modeling result for each parameter, the regular interval method was used. The measurement interval was 12 hours and 24-hour equal interval, with the interval 6 hours for each parameter to determine change in the concentration value from 6 hours to 24 hours. For the period of 6 months, a different interval was used, which is the average of concentration value for 6 months. Feature 3 show the map of direction and speed of the wind or windrows at the location. Based on the windrows map, it can be seen that the dominant wind direction during the period of 6 months, July until December, was to southeast by 162 degrees, with the maximum wind speed of 7.5 until 9.9 meter per second at 6.93%, which is equivalent to 306 times of the overall wind blows. The maximum wind speed range is the 7.5 until 9.9 meter per second class at 19.6%. The minimum wind speed is in the 15.3 until 18.3 class at 1.5%. The average wind speed in 6.19%. The frequency of the calm wind, which the R wind with the speed below 0.5 meter per second, is 0.75% with wind blowing 33 times. The sulfur dioxide, nitrogen dioxide, and the particle dust emission spreading modeling were done from the emission source, which were the chimney. The topography of the study area is relatively flat and has one chimney. The emission spreading modeling result includes a map for isotope concentration above the ground level. The result of emission modeling for sulfur dioxide parameter for 6 hours, 12 hours, 24 hours, and the period of 6 months had the maximum and minimum concentration value of 13.70 and 0.30 microgram per meter cubic. 9.67 and 0.09 microgram per meter cubic, 7.70 and 0.08 microgram per meter cubic, and 2.24 and 0.02 microgram per meter cubic respectively. The dominant speed of sulfur dioxide emission moves toward the source, which is identical to the Windrose result. The maximum concentration value for sulfur dioxide parameter for 6 hours, 12 hours, 24 hours, the period of 6 months were still far below the ambient quality standard stipulated by the government regulation of Republic Indonesia of 900 microgram per Newton meter cubic. The result of the emission spreading modeling for nitrogen dioxide parameter for 6 hours, 12 hours, 24 hours, and the period of the 6 months had maximum and minimum concentration value. The maximum concentration of the nitrogen dioxide spreading emission was located at VT Desa Air Cargo, the same place of the sulfur dioxide spread. This is due to the maximum concentration to the southeast of the emission source based on the Windrose. In figure 7, yes, nitrogen dioxide emission released from the chimney can be observed. Nitrogen dioxide concentration increasing instantly to the maximum concentration of 4.70 microgram per meter cubic with a spread area of 33576.395 meter quadrat. Nitrogen dioxide concentration slowly decreased until it increased to 3.66 microgram meter cubic with the spread area of 456,771.525 meter cubic. After that, the concentration decreased because the move away from the emission source and the spread area of becomes 735.25.215 meter cubic. According to the government regulation of Indonesia, number 41 in 1999, the ambient air quality standard for nitrogen dioxide is 400 microgram per Newton meter cubic. The maximum nitrogen dioxide concentration value result for 6 hours, 12 hours, 24 hours of the period of 6 months were still within the ambient air quality standard of Indonesia, spreading from the chimney of the VT Cement Egg Indonesia. From the area comparison result features 8, it can be seen that the concentration of the particle, the emission coming up the chimney, which the concentration of the particle dust increase instead the maximum concentration of the 13.83 microgram meter cubic with a spread area 367,016.529 meter cubic. The particle concentration decreased to 5.47 microgram per meter cubic and increased again with the area of 663305.593 meter cubic. After that, the particle concentration continued to decrease and the extent of the spread area was 1578482.571 meter cubic. The particle concentration continued to decrease and spread to wider area until reach heat 0 778079.648 meter cubic. This becomes the level of the particle concentration is influenced by the wind speed, whereby the more the winds blow, the lower of the particle concentration and the wider of the spreading area. Otherwise, when the wind blows weakly, the particle concentration increase and accumulation in the location that they close to the source of its emission. According to the Government Republic of Indonesia, the ambient of quality standard of particle dust is 130 microgram meter cubic. Therefore, the maximum particle concentration result for 6 hours, 12 hours, 24 hours, and the period of the 6 months were still within the ambient air quality standard. Conclusion, based on the research and the Aermod modeling for the prediction of the sulfur dioxide, nitrogen dioxide, and the particle dust emission spreading pattern from the PT Semen X Indonesia, it is known that the spread of the emission volume that moves southeast and occurred for 6 hours, 12 hours, and 24 hours, and within the period of 6 hours for the sulfur dioxide emission pollution had the maximum concentration of the 13.70 microgram per meter cubic and 9.637 microgram meter cubic, 70 microgram meter cubic, and 2.24 microgram meter cubic, respectively. For the nitrogen dioxide emission pollution, the maximum concentration was this is. The region of the continuously got the maximum concentration value from the sulfur dioxide, nitrogen dioxide, and the particle dust spreading that come from the PT Semen X Indonesia for each hour was PT Desa Air Cargo Industrial Area with the UTM coordinate point. However, the maximum concentration value did not exceed the established quality standard. Thank you very much for the chance given to me the presentation, the research. I think enough. Thank you. Assalamualaikum warahmatullahi wabarakatuh.